All right, so today we're going to be working on Chapter 5, Lesson 3, Dividing Polynomials. So what we're going to learn today is we're going to learn about dividing polynomials using long division and dividing polynomials using synthetic division. So both of these things serve the same function. Long division is kind of similar to how you learned how to do long division when you were in elementary school. And then synthetic division is more of a kind of shortcut way of a more algorithmic way of doing long division, kind of more shorthand. So some of the vocabulary you're going to have to know is just what is synthetic division. So long division, right? So in lesson 5.1, we learned how to divide monomials. So today we're going to learn how you could divide a polynomial by monomial using those same skills. So let's look at an example. So dividing a polynomial by a monomial. So here is an example where we have a polynomial, right? A polynomial with 3 terms divided by this monomial, 4xy. So one way that we could do it is we could take the problem and we can just write it in expanded form, right? It's basically all of these things each being divided by 4xy. So take the first term divided by 4xy, take the second term divided by 4xy, take the third term divided by 4xy. And then each one of these you can simplify based off the skills you used in 5.1, right? So when I'm doing this, right, 4 over 4, x to the third over x, right? So you can subtract their exponents, y to the second over y, subtract their exponents, plus the second term, right? 8 over 4, x to the first divided by x to the first, subtract their exponents, y to the second divided by y, subtract their exponents. Same thing in the third term. You have 12 over 4, x squared over x, which is subtracting their exponents, y to the third over y, subtract their exponents. And then the last step there is just to simplify it, right? So 4 over 4 is 1, x to the power of 3 minus 1 is x squared, y to the power of 2 minus 1 is just y to the first or y, plus 8 over 4 simplifies to 2, x to the first, or x to the power of 1 minus 1 is x to the 0 power, and obviously x to the 0 power is equal to 1. And then y squared, or y to the power of 2 minus 1 is just y to the first, so that's why you're left with just 2y there. The third term, you have 12 over 4, which simplifies to 3. This will leave you with x to the first power, and then this will leave you with y to the second power. So again, this is what it looks like when you get it simplified. So in this example, we were able to, when we're doing a polynomial divided by a monomial, you can break it out so each term is just divided by the denominator and then simplify each one of those terms until you get your simplified answer. So you can use a process similar to long division to divide a polynomial by another polynomial with more than one term. The process is known as the division algorithm. So when doing the division, remember that you can only add or subtract like terms. So we're going to use that idea to help us move through this. So let's use the division algorithm here. So if I wanted to use long division to take z squared plus 2z minus 24 and divide it by z minus 4. So I have a polynomial with 3 terms divided by a polynomial with 2 terms. So if you remember elementary school, we would use the division symbol here, right? So we have z minus 4, right, dividing into z squared plus 2z minus 24. So really similar to what we learned, but now we have some variables and we're using polynomials. So we're going to go ahead and start by, okay, well, kind of how you used to break it out before. We have z minus 4, and I have to start dividing it into this. So what I can do is what times z minus 4, or what times z is going to give me z squared? And that's going to be z, right? So z times z is z squared. Z times negative 4 is minus 4z. So here I have z squared minus 4z, right? I multiply both of these by z. It gives me these terms here. And then just like we learned in elementary school, now I'm going to subtract these from these. So z squared minus z squared is 0. 2z minus negative 4z, which is like 2z plus 4z, which is going to give me 6z. And then, so now this is what I'm left with here. So now I'm going to drop down the next term. So that's going to be 6z minus 24. And then again, up here, what times z will give me 6z? Well, that's going to be 6, right? So 6 times z is 6z. 6 times negative 4 is negative 24, right? And then I'm just going to go ahead and subtract them. So 60 minus 60 is 0. Negative 24 minus negative 24 is also 0. So and there's nothing left to drop down. So this is my remainder. I get a remainder of 0. So my answer is sitting right up here. If I take this polynomial and divide it by this polynomial, this is my quotient. This is my answer. So my answer is z plus 6. So again, really similar to how we used to divide larger numbers in elementary school, but now we're using polynomials. We're using that same process. So let's go ahead and look at a little bit more. It says, just as with division with whole numbers, the division of two polynomials may result in a quotient with a remainder. So remember that 9 divided by 4 is equal to 2 with a remainder of 1. It is often written as 2 1/4, and so the result of a division of a polynomial with a remainder can be written in a similar manner, because it's not always going to work out that we have a remainder of 0. So let's look at a problem with a remainder. So here's an example. This would be an example of like a multiple choice test. It says, which expression is equal to t squared plus 3t minus 9, right, that quantity, times 5 minus t quantity to the negative 1 power. So if you remember about negative exponents really refer to its reciprocal, right? So really it's like dividing, right? So if we look at that second exponent of a negative 1, it's really like a division problem, right? So this negative 1 exponent really drops it down in the denominator of a fraction. So really this is division. So if I were to look at this problem here, it's this 3-term polynomial divided by this 2-term polynomial, right? A trinomial divided by a binomial. So I'm going to go ahead and use my division algorithm here to help me solve this problem. So again, I'm going to do this polynomial, right, divided by this binomial. And I just rewrote it, so the variables out front, it just makes it a little bit easier as we go through this process, right? 5 minus t is equivalent to negative t plus 5. So again, what times negative t gives me t squared? Well, that's going to be negative t, right? Negative t times negative t is positive t squared. Negative t times 5 is negative 5t. And then I'm going to go ahead and subtract, right? So t squared minus t squared is 0. 3t minus negative 5t, that's like plus 5t, right? That's going to give me 8t. And then I'm going to go ahead and drop down this minus 9. And then same thing, what times negative t gives me positive 8t? That's going to be negative 8, because a negative 8 times negative t is positive 8t. Negative 8 times 5 is going to give me negative 40. And then I'm going to go ahead and subtract these. 8t minus 8t is 0. Negative 9 minus negative 40, that's like plus 40, right? So that's going to give me positive 31. And again, there's nothing left to drop down. So this is going to be my remainder here. And if remember, your remainder just is a fraction over whatever you were dividing by. So my answer is going to be negative t minus 8 plus the remainder 31 over 5 minus t, right? Whatever I was dividing by, right? So in this circumstance, I could see that my answer is in fact C here. So now we're going to move on. So that's kind of the long division way. So now we're going to talk about synthetic division, right? So synthetic division is basically the same idea, but using a simpler process for dividing a polynomial by a binomial, okay? Suppose you want to divide 5x to the third minus 13x squared plus 10x minus 8 by x minus 2 using long division. So we were going to use our method that we just learned. We would set it up in a similar way, right? So we're dividing by x minus 2. We're dividing it into this polynomial, right? So we're going to go ahead and divide in just like we did previously did, right? So what times x gives me 5x to the third? That's going to be 5x squared, right? 5x squared times x is 5x to the third. 5x squared times negative 2 is negative 10x squared. And then again, I'm going to subtract. So that minus that makes 0. That minus that makes negative 3x squared, right? Because minus and negative is like adding. And then I'm going to go ahead and bring down my 10x here. And then what times x gives me negative 3x squared? That's going to be negative 3x. So negative 3x times x is negative 3x squared. Negative 3x times negative 2 is positive 6x. So again, subtract. That minus that makes 0. 10x minus 6x makes 4x. Again, let's drop down the minus 8 here, the next term. And so what times x gives me 4x? That's going to be 4. So 4 times x is 4x. 4 times negative 2 is negative 8. And so now I can see when I subtract, that's going to leave me with a remainder of 0. So here's my answer right here, 5x squared minus 3x plus 4. So that's using the long division way. So now I'm going to show you what that looks like using synthetic division. It's kind of a simpler process for doing the same idea. So in this example, it says, hey, use synthetic division to divide the problem we just did, right? This divided by this. So the first step is you're going to write the terms of the dividend, right? So that the degrees of the terms are in descending order, then write the coefficients as shown to the right. So first we're going to make sure that this is written in descending order based off the coefficients, based off the degrees, right? So the exponents. So we have the third power, the second power, the first power, and then obviously the 0 power because the variable has 0 power here because you don't see it. So now we're just going to only write the coefficients. We're only going to write the leading numbers there. So we're going to write 5, negative 13, positive 10, negative 8. So all we need is these numbers now. So the next step is we're going to write the constant r of the divisor, right, the thing we're dividing by, x minus r to the left. In this case, if it's x minus r happens to be 2, right? It's always x minus r. So if it said x plus 2, then the r would be negative 2, right? So it's always x minus r. So r is really the kind of the opposite of what you see there, right? So in this circumstance, r is going to be 2. So we're going to write 2 right here, okay? And so this is going to be our setup for synthetic division right here, right? We have all our leading coefficients from our dividend, and then we have our r from our divisor, and now we're going to go through the process. So the first step is we're going to bring down the first coefficient, right? So 5 automatically gets dropped down to the bottom here, okay? So the next step is we're going to do 2 times 5, okay? We're going to do 2 times 5, which is 10. Right? 2 times 5 is 10. And then I'm going to go ahead and add these numbers. So negative 13 plus 10 is negative 3. The next step is I'm going to do 2 times negative 3. So 2 times negative 3 is negative 6. Right? 10 plus negative 6 is 4. Okay? So now I'm going to do 2 times 4. 2 times 4 is 8. And negative 8 plus 8 would be 0. So this has a remainder of 0. So now what I want you to notice is look at these numbers right here. These are going to be the coefficients to your answer, okay? And since the coefficients to your answer are always going to be 1 degree lower than what you have here, that means this is going to, instead of being 5x to the third, it's going to be 5x squared minus 3x plus 4. So this would be my answer here. So the numbers along the bottom row are the coefficients for your quotient, your answer. So you start with the power of x, 1 less than the degree of the dividend. So here, since it was the third, this is going to be the second, then the first, then 0. And so again, our quotient would be this. So let's look at that side by side with long division. So here's what it looks like using long division. Here's what it looks like using synthetic division, right? We still get the exact same answer. Look, here's our answer using long division. Here's our answer using synthetic division. Look how much space long division takes up. Look how much space synthetic division takes up. So they do the same thing. It's just that this is a kind of simpler algorithmic process than this one. So, but either strategy works. Let's look at one last problem. If you want to use synthetic division, but the divisor must be in the form of x minus r, right, the thing you're dividing by, the coefficient of x in the divisor is not 1. You can rewrite the division in expression so that way you can use synthetic division. So here's an example. We have 8x to the fourth minus 4x squared plus x plus 4 divided by 2x plus 1. Notice how this is not in the form of x minus r, right? This is not a coefficient of 1. This actually has a coefficient of 2. So we can rewrite this so it does have a coefficient of 1. All right, so let's go ahead and look at what that looks like. So really, this problem can be written like this, right? The polynomial divided by that polynomial. So if I wanted to take this and I wanted to turn it into a coefficient of 1, all I would have to do is divide everything by 2. So if I divide 2x plus 1 divided by 2, I can do that as long as I divide everything in the top by 2. So that's what I'm going to do, divide both the numerator and denominator by 2. So when I do that, 8x to the fourth divided by 2 is 4x to the fourth. Negative 4x squared divided by 2 is negative 2x squared. 1x divided by 2 is 1 half x. 4 divided by 2 is 2. And then on the bottom, 2x divided by 2 is x. And 1 divided by 2 is a half. So now I can use synthetic division because now I have a coefficient of 1. So in this scenario, right, since the numerator, the other thing I have to keep track of is notice how I have to the fourth power, second power, first power, zero power. Notice how I don't have a third power. So I am going to have to use 0 in this instance when I am using synthetic division. You do need to fill in those gaps. It makes the problem a lot easier so we're not missing a step there. So here are also the thing to keep in mind is what is our R term? So if it's x minus R, right? And it says x plus 1 half, well, it's got to be a minus. So this is actually, our R is going to be negative 1 half, right? It's got to be the opposite of what's there. So it's going to be negative 1 half. So that's what we're going to use as our R. So let's go ahead and set up synthetic division here, right? So we have negative 1 half as our R term. Here are all the coefficients from our polynomial. And like I said, I'm putting a 0 in for the third term, right? Because this is 4x to the fourth. And this is 0x to the third because we don't have an x to the third, minus 2x squared plus 1 half x plus 2, right? So I needed to write them all out. Make sure you fill in a 0 for any exponents that are missing in between. And then now I'm going to go ahead and start synthetic division, right? I'm going to go ahead and drop down the 4, right? Negative 1 half times 4 is negative 2. And then go ahead and add these. 0 plus negative 2 is negative 2. Negative 1 half times negative 2, and negative times negative is a positive. 1 half times 2 is 1. Add these together. Negative 2 plus 1 is negative 1. Now I do negative 1 half times negative 1. Negative times negative is a positive, so it's positive 1 half. Then I add 1 half plus 1 half is 1. Negative 1 half times 1 is negative 1 half. And then 2 plus negative 1 half is 3 over 2, right? It's positive 1 and 1 half, and I'm going to write it as an improper fraction, 3 over 2. So this is my remainder here. So really my answer is, again, remember you start 1 degree lower. So since what I was, my dividend was to the power of 4, so this is going to be the power of 3. So it's 4x to the third minus 2x squared minus 1x plus 1. And since it's positive, it's plus 3 over 2 over the divisor, which was x plus 1 half, right? Because that's what I was dividing by in this problem here. So now, this looks kind of ugly though, right? I actually need to fix this so that way I don't have all these fractions in a fraction. So I'm going to go ahead and simplify it. So when I simplify it, I'm going to go ahead and rewrite this. So really, this is just a division problem, right? 3 over 2 divided by x plus 1 half. So another way that I could do this, I could go ahead and write it as a multiplication problem, right? Any division problem can be written as a multiplication problem by multiplying by its reciprocal, right? Oh, sorry, I was going to simplify this first. So x plus 1 half can just be written as 2x plus 1 over 2, right? Because if you were going to add these and make them common denominators, right, I put it over 2. So x is just 2x over 2. Add them together, you get 2x plus 1 over 2, right? Here it is right here. And then I'm going to turn this division problem into a multiplication, right? Multiply by its reciprocal. So the reciprocal of 2x plus 1 over 2 is 2 over 2x plus 1. And then I can go ahead and just multiply across, right? The other thing I can notice too is that these 2's cancel out, and it just leaves me with 3 over 2x plus 1. So this whole thing here simplifies into this. So my final answer I would write as 4x to the third minus 2x squared minus 1x plus 1 plus 3 over 2x plus 1. So since I know this is my solution now, I could just go ahead and double check it using long division if I wanted to. So this is what it looks like using long division. You can walk yourself through the process there. And I see that I get the answer of 4x to the third minus 2x squared minus x plus 1 with a remainder of 3. So it'd be 3 over 2x plus 1, which is the exact same answer that I got using synthetic division. So again, either strategy works, you end up getting to the same answer. So let me know if you guys have any questions. Thank you guys for watching.